I apologize for this, Ben. But you're getting a live class 1. Okay, I want to start by asking you.
Remember when you sat next to me in math class?
He doesn't want to remember.
It was crazy, right?
Yeah, they haven't changed.
What is the reciprocal?
Well, that's what we're starting with. So if I'm going to do the reciprocal of a binomial, the first thing I want you to know is that this is a binomial. It's made up of 2 terms that are not like terms. So let's use the words correctly. And you know a few things about that. You should know what the word reciprocal means. The reciprocal of any number is the number that when you multiply by that number, you get the number. Oh, dear God.
Opposite.
You get the number 1. Reciprocal is the number that when you multiply by it, you get the number 1. And if I give you that number line I gave you a long time ago, or just last semester, where I have 1 in the middle, and on the right side I have positive infinity, and on the left side I have 0, and I know that every number between 1 and infinity has a reciprocal between 0 and 1. They match up very, very evenly. So let's go back to this thing. I'm going to erase this and go to the reciprocal of 1 over, or is 1 over. That's the easiest way to get a reciprocal. Because if I were to take 1 over root 5 minus 1 times root 5 minus 1, what do you get? 1. However, this is not simplified. For the very, very reason that we have a radical in the denominator, it's not simplified. At least it's not in simplified radical form. Because there is. So we're going to go back to this number and figure out how to simplify that. Because while it is partial points to put 1 over root 5 minus 1, and I would give you an emotional but not a physical pat on the back because it's 2019 and that might be construed in a different way, and this is being recorded. Okay. And but if I were to do this, it'd be good to put that. It's just not complete. I need a way to get that out. So period 8, in one of their less than stellar moves, decided that we would multiply by root 5 over root 5. They did. And so we did. And we get 5 minus root 5. So then they decided to multiply by another root 5. And we let that go on for a little while. So then another genius decided we would multiply by root 5 minus 1 and root 5 minus 1. Because, before we multiplied by the same things. You see the issue with that one. You are going to FOIL this, first, outer, inner, last. But your outer and inners are going to still have a root 5 in there. So, pray tell, give me the one that you have. Thank you. I'm so
smart.
I hope your voice is being picked up here. Yeah. We're going to go root 5 plus 1. But the better question that I'm going to ask one of you is, what is the word for root 5 plus 1 relative to root 5 minus 1? There was a word we used. Close. The opposite of root 5 minus 1 is actually negative root 5 plus 1. So that's different. It is the conjugate. So this is the conjugate. And the conjugate, multiplying by the conjugate of the binomial, is the only operation we have that is going to square both parts of the binomial. So when I do that, I get a root 5 plus 1 over, let's check my first, outer, inner, last. First is 5. Outer and inner cancel each other out, right? Plus root 5 minus root 5. And the last is minus 1. So this whole thing simplifies into root 5 plus 1 over 5 plus root 5 minus 1, which is 4. And that gives me a radical not in the denominator. And if I knew the value of radical 5, I could add 1 to that and divide by 4 without too much difficulty. So that's the point and the big part of what we're doing today. Multiplying by the conjugate is the only way, or we'll say is the only operation that squares across a plus or minus. It's the only operation that squares across a plus or minus. You can never, ever, ever, ever do any sort of exponent or radical across a plus or minus. And even as I say that, I had, and you can count them, because I did, 57 murdering of puppies occur on yesterday's quiz in period 8. I graded theirs. 57 instances of puppies dying in period 8. I'm going to pause this for a second because Ben doesn't want to see this 7,000 times. Okay.
You should just drop the mic, but that was pretty good.
I've got more. I did a lot at the start of the school year, and you're the only one that picked up on them.
Me and Claire are the only one that picks up.
I pick them up.
Okay, let's do the next one. 1 over root x minus root y. When you have, guys, please. When you have ones like this, I get some questions happening. What are we going to multiply by first?
Square root of x plus square root of y.
Please don't overthink this. I know that when I multiply root x by root x, I'm going to get x. Don't do the absolute value of x, and the reason is a little bit beyond the scope of the class. But if you did the absolute value of x, you don't need it because the original problem x couldn't have been negative, so in the final x can't be negative as well. But when I multiply this, I get root x plus root y over what?
1. X plus. I was really waiting for you. X minus y.
X minus y.
Is that it?
That's it.
Oh, what? That was way too quick. That's pretty good.
Number 3.
Do the earphones just so that you can listen?
No, it's because the mic's right here. It's a better microphone. It keeps it.
That's a microphone.
Yeah.
I just thought it would, I thought you could control volume from that.
Yeah, it's also a mic.
That's multi-purpose.
Okay, is there also a pause button
Wait,
on it?
simplify. Go.
And
Andrew.
it calls
Andrew.
Siri?
Andrew.
It does not call Siri. It just
Fully R? It just fully air. Oh no, I went to Siri's voice.
Well, this is crazy.
Okay. What are we multiplying by?
Well, 2
Yes,
plus
sure.
7.
Is that plus 7?
Yeah. I say that because I have people multiplied by root 3 plus root 5, which would be fine if our goal was to rationalize the numerator, which will actually be a thing you do in a later course. But in this course, that's plenty. So the numerator, we're just looking to FOIL. First, root 3 times root 2 is?
Root 6.
Root 6 plus
Root 21.
minus root 35, and that's over 2 minus 7.
Can we simplify that?
We can a little bit, not in a way that you're going to like, but I can make 2 minus 7 be negative 5. Okay, that's 1.
Wait,
And-
we get 2 minus 7?
Well, it's not. You're right. That looks ugly. I am actually counting the number of negatives we have. I have 3 negatives. Can I multiply both the numerator and denominator by negative 1 and make it,
Yes.
like, switch the signs on everything? Make it root 10 plus root 35. Yes, Jacob?
Oh, never mind.
Oh my
All over what?
5.
5. And so then we have 2 negatives and not 3 negatives. It's considered slightly simpler.
And then do you factor everything out?
Yeah, you can't. That's done.
Are you sure?
They're not like terms up in the numerator. There's,
Are you sure?
Are you sure?
You're not factoring anything out.
If-
If someone has
it's we can't because they're all radicals, and that just it starts to run the gamut of what is it that we're really trying to do here.
There's not even some sort of math genius thing you can do.
Really nothing.
What do you just do?
I circled it.
From the middle to the bottom.
I multiplied both the numerator and denominator by negative 1 because I have 1, 2, 3 negatives here, but in my final answer I have 2 negatives. So it's actually just considered to be fewer. It's slightly simpler.
Because negatives are
So
so
if I get a half point off.
Don't be mad.
Would you take off points?
Oh yeah, would you take out points for that if we had 3 negatives?
Is that the only thing that matters in life?
Yes.
In this
Yeah,
class?
the only thing that matters in this class,
Because
really.
that gets us into a good college, and the good college gets us into a job, and that job will get us money, which is the only thing that matters in life. There we go, Jacob. There we go. I'm sorry, I've been raised with these values, and I can't just let them go.
Andrew, do you have those same values?
No, all that matters is love.
Jacob,
Oh,
Jacob, can you tell this class about your spy mission?
Later. Let's finish this so Ben can get off and do whatever he needs to do.
I
Okay.
want to hear about his spy mission.
Evaluate when x is equal to root 3 plus 1.
No, Ben wants to hear about it too.
So what does that mean?
Good quote. You're going to plug in.
Yep. We're going to plug it in to each part of the x. So really we get f of root 3 plus 1 equals root 3 plus 1 minus 2 over root 3 plus 1 plus 1.
All right.
So yeah, we gotta simplify.
Negative, or there's a root thing in the denominator, Andrew.
I got,
If you leave it there,
I
we'll
was
all
thinking
die.
negative, okay?
Hey.
Well, again, the goal of having a radical not be in the denominator is that you should be able to approximate these things without too much mathematical difficulty. So if I multiply this by root 3 minus 2, root 3 minus 2, the numerator becomes, okay, root 3 times root 3, 3, minus 2 root 3 minus root 3 plus 2 over 3 minus 4.
Oh, I just love that.
Which gives me 5 minus 3 root 3 over negative 1, or 3 root 3 minus 5.
Ben, save us from being held captive.
I can nerd out and think it's the neatest thing that this value, which you can't do by hand, is the same as this value, which it's not too difficult to take 1.7, multiply it by 3, and subtract 5. So that's final. Continuing on.
Is 6.4 going to be on our quiz?
Negatory.
Wait, why is it 5?
That would be
And
a-
then when you oh, you know what? Because
Could you
Yeah.
multiply
5's
both
at the back.
by
5's at the
negative-
back.
yeah,
Got it.
No.
It's terrible.
What this means, if I'm saying show it's a root, is show that when you plug it in, it works. It's not meant to be anything more than that. 3, 1 minus root 3 over 3 squared, minus 6 times 1 minus root 3 over 3 plus 2. Can you square this without writing it next to itself? First would be 1 minus root 3 over 3 minus root 3 over 3, so minus 2 root 3 over 3.
Wait. It says squared, so.
All right.
So the answer is no. Let's write it by itself. 1 minus root 3 over 3, 1 minus root 3 over 3. First, 1. Outer, minus root 3 over 3. Inner, minus root 3 over 3. And last, plus 3 over 9. So I'm going to go back to the original problem now, and let's make this 3 times 1 minus 2 root 3 over 3 plus, let's simplify the 3/9. 1/3.
Wait, how did we get 3/9?
Root 3 over 3 times root 3 over 3.
Oh.
I'm going to do last.
I was looking.
Minus 6 plus 2 root 3 plus 2. Sorry, that square is not there.
Yeah.
And then distribute the 3. 3 minus 2 root 3 plus 1 minus 6 plus 2 root 3
Wait, isn't it 3 minus 6 root 3? It's 3 times 2 is 6.
over 3.
Oh, yeah. 6 divided by 3 is.
Or just cancel the 3's when you multiply it in. And then these go. And what is 3 plus 1 minus 6 plus 2?
0.
God, I hope it's 0, because that's what it was supposed to be, way up at the top. And when you're done and you see that, oh, yay, look, it is 0, rather than circle that and draw a smiley face, you can put this, QED, which is Latin for quod erat demonstratum. It's a mathematical proof word that means thus I am finished, or I am shown it's true. Or if you're less pompous, you can put a little thing there. So the top one would be if you're an AirPod person, and the bottom one would be if you're like a normal person, you just want to show that you're completed.
Wait, what did the square come from?
The square means I'm done. I've shown it.
I just write done. Or just write that thing.
We're done.